Now let's go on to limit of a function. We talked about the meaning of functions and the different kinds of functions we have and its examples. Today we are going to be looking at the limit of a function. Now let's look at the meaning of the limit of a function. The limit of a function denoted as this. This is the correct representation of the limit of a function. Represents what happens to the function x. In this case, you are looking at the variable x, right? As it gets closer to a specific value of a. So, limit of a function is just telling us that what happens to this function x as it gets closer to a specific value. In this case, the value is a. So when we say limit of x as x tends to a, we are actually saying what happens to x as it tends to a. Is it increasing? Is it decreasing? Is it approaching a true function? Is it approaching a false function? And so on and so forth. So now it captures the limit of a function. The limit captures the behavior of a function as it approaches a particular point without necessarily reaching that point. Is that okay? Now this concept enables us to study the continuity of derivatives and integrals, and it forms the basis of these calculus branches. So these are the practical usage of the limit of a function. Now let's understand the notation. The notation limit of x signifies the following. It signifies that y is a function of x. Y is equal to f of x. So that's what it signifies, and it can be written like this. Is that okay? So this can be represented correctly as the limit of f of x as x tends to a. So this is the limit of the function of a function of x as the variable x tends to a specific value a. Is that okay? Now x represents the variable approaching a certain value of a. So this is the slight explanation that will be given under the limit of a function. Let's go on to some examples, some solved examples on the limit of a function. Now evaluate the following. Question 1 says, what happens to this function x plus 4 over x minus 3 as the variable x tends to 3? That is what this number 1 is saying. Limit this function as it tends to 3. Now what do we do to solve that question? You just put the value of x, or where the value it tends to, into the function. So we just put 3. So we have 3 plus 4, then we have 3 minus 3, and 3 plus 4 will give us 7. 3 minus 3 will give us 0. 7 divided by 0 will give us infinity. Infinity how? Okay, recall I said in the last video that 0 divided by x is equal to 0, and x divided by 0 is equal to infinity. So any number divided by 0 will equal infinity. Now let's move on to the second example. Now the second example says, what happens to this function x plus 3 and so on and so forth as the limit tends to plus 1. Is that okay? Good. As the limit tends to plus 1, what do? We just put the value of 1 into this function. So instead of x, I have 1. 1 plus 3, 2 times 1. So 1 plus 3 will give me 4. 2 times 1 will give me 2. Then 2 minus 1. 2 minus 1 will give me 1. What is joining the both of them together? Multiplication. That's bracket, right? Which is multiplication. That's why I have 4 times 1 here. I have x squared. Putting 1, so I have 1 squared plus 3 times x. That's 3 times 1 is 3. That's minus 2. Now 3 minus 2 will give me 1. So I have 1 squared plus 1. 1 squared is 1. 1 plus 1 is 2. And 4 plus 2 will give us 2. So what happens to this function as it tends to plus 1 is that it gives a value of 2. So this function will give a value of 2 as the variable x tends to plus 1, or the positive value of 1. Now let's look at the third function. The third function says find the limit of this function as the variable x tends to 3. Okay, so what we just do is that we put the value of x, which is 3, into this function. So instead of x raised to the power of 4, I have 3 raised to the power of 4. Now 3 raised to the power of 4 is 3 times 3 times 3 times 3. That's 3 in 4 places, which will give us 81. Okay, and 3 raised to the power of 3 is 27 also. So 81 plus 2 give me 83. 27 minus 27 give me 0. 83 divided by 0, like in the first example, will give us infinity, because any number divided by 0 will give us infinity. Wonderful. So I'm sure with this example we have been able to understand what the limit of a function actually means. It is telling us the value that that function will give as the variable tends to a certain value. Now tune in for the next video under this section. Thank you for watching.